Solving equations by undoing.
Undoing is a method of solving equations by using inverse operations.
We will now learn by the method of several examples. So in example numero uno here, we've got x and it's got all this other crap going on with it. Our goal is to isolate x to find out what the value of it is.
In order to do that, we want to make a chain. To make a chain, let's first think about this. What if we wanted to substitute x equals 3 into our equation? By order of operations, you would first add 5 to 3. So the first thing that we're going to put in our chain is a plus 5. The second thing that you would have to do if we were trying to calculate the left-hand side of this equation is to multiply by 3. So the second piece of our chain is going to be times by 3. The third thing that happens on the left-hand side of this equation is this minus 6. So that's the third step in our chain of minus 6.
So remember that our goal was to isolate x. What we want to do now is undo the chain. In order to do this, we're going to do the operations of our chain in the opposite order and the inverse operations. Now our chain before was plus 5 times 3 minus 6. So what we're going to do now is write the inverse of subtracting 6 first. That would be adding 6. Next we would do the inverse of multiplying by 3, which is dividing by 3. And our last step would be subtracting 5, which is the inverse of adding 5.
All right, so our undoing chain is add 6, then divide by 3, then subtract 5. If we're going to do all of those operations on the left-hand side of our equation, then we need to do them on the right-hand side as well. So let's do it all together. So 3 times x plus 5 minus 6 equals 15. We first are going to add 6 to both sides. Okay, then that will leave us with 3 times x plus 5 on the left-hand side, and 15 plus 6 is 21, so 21 on the right-hand side. Then we're going to divide by 3 on both sides. All right, so that leaves us with x plus 5 on the left-hand side, and 21 divided by 3 is 7, so 7 on the right-hand side. Last is subtract 5. So we're going to subtract 5 on the left-hand side, and on the right-hand side, we just have x equals 7 minus 5 is 2, so x equals 2. Ta-da!
We did it!
For this second example, it's your turn. Stop. You want to make a chain for all of the operations that are happening to the x.
Did you get this as your chain? I sure hope you did. What we did first was we subtracted 2. Next, we took the square root. Then we multiplied by 3.
Now take a second and reverse your chain. All right, this was the chain for this equation. To reverse it, I'm going to write it in the opposite order and with the inverse operations. So first would be divide by 3, then would be to square the whole thing, then we would add 2. Now we are going to perform each operation in the blue chain up here to the left and the right hand side of our equation. You go ahead and do that. Okay, so first we should be dividing by 3 on both sides. That will give us the square root of x minus 2 on the left-hand side and 8 over 9 on the right-hand side. Then we're going to square both sides. That gives us x minus 2 on the left-hand side and 64 over 81 on the right-hand side. Last, we're going to add 2 to both sides. So our final answer should be x equals 2 and 64/81.
You rock! I have made a mistake somewhere in this problem. First, I found my chain, which was multiplying by 3, subtracting 2, cubing, and then multiplying by -2. I reversed that chain, saying that it was dividing by 3, adding 2, taking the cube root, and then dividing by -2. I got this answer. What did I do wrong?
If you said that we forgot to reverse the order of our chain, you were right. The chain that we should have used to isolate x would be divide by -2, take the cube root, add 2, and divide by 3. Be careful when reversing your chain. The end.